Okay, so this function f of x equals 9x minus 1, when you graph that, I put it in here and graphed it, that's just a line. Now, if we think about what we could put in for inputs, we could put in, let's say, if we hit trace, we could put in -5, hit enter. It's going to tell us that that's at -46. We could put in 2, hit enter. That's going to tell us we are at 17 up high here. We could put in 1, hit enter. In fact, we can put in anything. We could put in 100, we could put in -100, we could put in 0.1, we could put in -4. So the domain is, the x values could be -infinity to infinity. What could the outputs be? Well, those could be anything too. I mean, we could get 1,000,000, we just put in like, I don't know, 500,000 or something, and it's going to shoot up to 1,000,000. If we wanted to get 0, we could put in 0. If we wanted to get -1, we'd put in like 0.1 or something. We could get anything, so the range is also -infinity to infinity. All right, B. G of x is equal to 3 to the x. So we put in 3 to the x power, we hit graph. Now this graph starts over here and it keeps increasing and increasing and then starts really increasing. Going the other way, it's decreasing and decreasing and then it gets closer and closer to that x-axis but never touches it. So let's take a look here. We could put in trace, we could put in 1 and we're going to get out 3. We could put in 2, we'll get out 9. 2 gets out 9. We could put in -1, and we're going to get out, when x is -1, we get 0.3 repeating. -2, a little further over, we get 0.1 repeating. -3, we get 0.03. So you see, as we move this way, this gets closer and closer to 0, but never touches 0. -8, we get, this is like exponential notation for something really small, but not quite 0. So the domain is, could we put anything in? Sure, we could put in -1,000,000, we could put in 1,000,000, and we get something out. But the range here, if you think about it, we're never going to get anything larger or 0 or less. If we put in -1,000,000, we're going to get something super tiny. It's going to shoot up like 0.000000001, but we're never going to be able to get 0. Even if we go to like -1,000,000,000,000, it's going to shoot up a little bit. So we can't get anything 0, so the outputs, or f of x, are only numbers greater than 0. So for this one, a of x is equal to x plus 2. Let's see here, x plus 2, we hit graph, there it is. But now we're restricting our domain. It says that the domain is just positive integers. So that means x is greater than 0 and x is an integer. So in other words, 1, 2, 3, 4, etc. So what do we get when we put in 1, 2, 3, 4? So that's the domain. So let's do trace. We put in 1 and we get out 3. We put in 2 and we get out 4. We put in 3 and we get out 5. So those are the pairs. 2, 3, 4, 5, 6, 7, or 5, 6, etc. So in fact, you can see that the range is just the numbers. You can get out 3, 4, 5, 6. So it's x is greater than 2 and x is an integer. Or you could just write it like this. All right, and the last one is h of x is equal to 5 to the x. So we type in 5 to the x, we get a graph, and it looks like 3 to the x, but it just accelerates even faster. Sorry, you can't see that. Accelerates even faster like this. But it has the same property. As it goes this way, it gets closer and closer to 0, but never touches. But this time we're only looking for the domain where for x is 0 to 4. So we're looking at from here, from here over to 1, 2, 3, 4 to here. Okay? So we're looking at that range from here to here. So let's see what happens when we put in 0. So if we hit 0, we hit enter, we get 1. So we could get 1 out. If we put in 2, we get 25. So we could get 25. What about 0.1? 1.17, 0.2, 1.379. So when we put in 0, we get 1. So we could get 1. And when we put in the upper limit, 4, so I just put in 4, it goes up to 625. So the range here is you can get anything from 1 all the way up to 625. So that's what we put for the range. The f of x, or the outputs, is from 1 to 625.